So I'm going to start talking about the chemical senses today and just the beginning of the taste system, which we will finish up on Monday, and then potentially also begin talking about olfaction or smell. Our chemical senses are really considered the gatekeepers, okay, that they are keeping us safe to a great extent, because when we are tasting something, we are taking that environmental stimulus itself into our body. And so it can either be safe or unsafe. And in the safe category, it can either be good for us or not really all that good for us, not really giving us much of anything. So what taste gives us is it lets us know which foods to eat and which foods to avoid. And so this is based on the quality of taste and its effect. Throughout evolutionary history, we have not had enough food many times in our evolutionary history, and other animals are in that same situation. And so for humans, we like sweet compounds, and we also like things that tell us that they have some kind of fat, because fat gives us fat to get us through the winter, and sweets give us some kind of energy. And so when we eat sweet compounds, we have this automatic acceptance response, and it prepares the gastrointestinal system for glucose and for something that is going to fuel the body. This is actually one of the problems with things like aspartame and artificial sweeteners, is that it tastes sweet. We're having this preparation of our gastrointestinal system as if we're going to get some kind of glucose for energy for our body, for our brain. If I haven't said it in this class enough, everything uses glucose. Our neurons use glucose in order to work. Everything uses glucose. And so if we're preparing for that and yet it's not actually coming because we're eating an artificial sweetener, then we're going to be more hungry and crave sweets more because of that interaction. We have bitter compounds where we have an automatic rejection response. Many of the poisons in the world are bitter. So strychnine, arsenic, cyanide are all bitter compounds. And oftentimes bitter tells us that something is poisonous and bad for us. We also have salty compounds, which tells us about the presence of sodium. We may crave sodium if our body needs sodium. So there are times when we are sweating out sodium, when we are requiring sodium, and we are craving sodium. The connection between taste and our bodily response is not always perfect. So my usual example is sweet compounds, which throw us off, those artificial sweeteners, but also with bitter compounds. Many of our bitter vegetables are obviously not poisonous, but they are extremely good for us. As I said early in the class, it is those green leafy vegetables that are nourishing our pigment epithelium and various parts of our brain and our sensory systems. They are really good for us. So this connection between what we know about taste and how the body is going to respond to those compounds, that's not a perfect connection. Much of our research on taste and different taste qualities have been done on 4 basic taste qualities, including salty, sour, sweet, and bitter. And so in the parentheses there, I have a really good example of each of these that are, the examples are specific to that taste quality. So sodium chloride tastes salty, hydrochloric acid tastes sour, sucrose tastes sweet, and quinine tastes bitter. Over the last, so I think it was in the 1990s, that people suggested that we might have, or it looks like we have, receptors that are responding to umami. A good example of an umami taste is monosodium glutamate, or MSG. It is sometimes described as savory or meaty. Okay, so I don't, I've mentioned to people that I get tired of my own cooking. I'm a vegetarian, and they go, "You're missing the umami." And I thought they were talking about my mommy's cooking. I was like, but no, they meant umami. I'm missing that savory kind of that whole taste quality. Don't think that actually explains why I'm tired of my cooking a lot, because I tend to cook the same meals, but nevertheless. The other, so that's a fifth basic taste quality that we've discovered, although most of the research that we're going to discuss, because throughout history they talked about those first four, but we also have added, even more recently, it looks like we have receptors for fatty acids and fats, and they have suggested that maybe we should call this oleogustus or oleogustus. Not sure how you say it, not sure it's going to catch on. There is no real consensus yet as to whether or not we should consider ourselves to have a receptor for this and what we should call it. But as I mentioned before, the things that we've needed evolutionarily throughout our evolutionary history are glucose, so knowing that something's sweet, and knowing that something has something that gives us fat, and those fatty acids can, we tend to crave fats sometimes as well, which suggests is one piece of evidence that we have taste receptors, that this is a basic taste quality. But actually, the way we examine whether or not we have taste receptors is through adaptation studies and cross-adaptation studies, and it looks like, again, researchers are finding that yes, we have some kind of receptors for fats or fatty acids. Even less research has been done on those, because that was in sometime in the mid 2000s, before 2010 is my memory of when they proposed fats or fatty acids as another basic taste quality. So mostly I'm going to be talking about those first four. And what you can see over to the right are some magnitude estimates. So the first one is a magnitude estimate of the four basic tastes, those qualities, to the taste of potassium chloride. And you can see that people said that was mostly salty, maybe with a little bit of bitter, but mostly salty. And if we do a magnitude estimate, so how much more salty is this, or how much of this flavor do we have in comparison to others? The sodium nitrate, that is rated as salty, sour, and bitter, and about equal components of those things. And those are much more strong tastes than sweet when we are tasting sodium nitrate. I'm going to go ahead and state right here, you do not need to know any of the chemicals that I mentioned for any of these. I was not strong in chemistry, and as far as I'm concerned, what the chemicals are telling us are about our taste receptors and our taste abilities, and that's what you want to know about, not the chemicals themselves. We really start talking about taste by talking about the sensory receptors, as we have for all of our senses. And this starts now at the papillae, actually, so really where the sensory receptors kind of, where they live or where they are housed. But I'm going to start with the filiform papillae. Actually, they do not have taste buds in them. The filiform papillae are shaped like cones, and they are all over the tongue. The fungiform papillae are shaped like little mushrooms, and they're found at the tips and the sides of the tongue, So you can see that they're slightly darker red. This is what's being shown really clearly on the tongue in the picture. The foliate papillae is this series of folds at the back of the tongue, and then behind that are the circumvallate papillae. So those are shaped like little flat mounds surrounded kind of like by a trench at the very back of the tongue. And I'm going to continue on. And so as I was saying, all of those papillae do have taste buds except the filiform papillae. And the filiform papillae are the ones in the center of the tongue. And so we basically have this blind spot for taste in the center of our tongue, which you can prove to yourself by going and getting a cotton ball or a Q-tip or something, soaking that in a sugar solution or a salty solution, whatever you prefer. Being careful to stick that right in the center of your tongue, not touching the tips or the sides of the back of the tongue. And you'll notice that it has no taste whatsoever. And then if you take that and move it so it is touching the tip, and then move it back to the center after it's touched the tip, you'll notice that you taste it now, and it tastes like, it feels like it's coming from the center of the tongue. Basically what's happening there is these papillae, so we have the taste cells on our tongues, but we also have mechanoreceptors, so that we are feeling the sense of touch through our tongue as well. We are feeling our food and things that are being put into our mouths. And so because we're feeling our tongue and we have a taste and something's hitting that center part of the tongue, it tastes like to us as if we are receiving the sensation of taste from that area, but we are not. The whole tongue contains about 10,000 taste buds. Each taste bud contains between 50 to 100 taste cells is the estimate. However, I will tell you that the estimate is that we have about 50,000 to 100,000 taste cells. And I know that that doesn't multiply out in any world, but those are the estimates I usually see, oddly enough. So I'm going to say we probably have about 100,000 taste cells from what I see and read and understand. We see those taste cells are going to protrude into these taste pores. So I'm going to save transduction for Monday because I'm getting a little low on time, but I'm going to walk through the picture, which I hope is big enough on your screen that you can see where the fungiform papillae, filiform papillae, foliate, and circumvallate papillae are on the tongue from that picture. And then Goldstein takes this area on the tip of the tongue, magnifies it so we can see the taste pore. We go into that and look at a taste bud, okay, down in the bottom left. And you can see it has this kind of looks like a bulb of garlic structure, okay, with the cloves of garlic then, as I'm talking about it. Those are actually the taste cells. And that little purpley blue area, that would be the soma of the cell. And if we pull out one of those cells that's coming together to make up our taste pore, I'm sorry, our taste bud, and then look at the top of that, that is what's protruding into the taste pore. So up where we're actually going to have chemicals touching the tongue. And then he goes and magnifies that in the very top right. And you can see where we have those taste receptors, okay, where we are going to actually be responding to things like salt, sweet, bitter, and sour. And so this is where I'm going to stop, and I'm going to start talking about transduction and how some of that occurs on Monday, as well as getting that to the brain.